Okay, we have the snow pile problem. Text is as follows. One pile of snow has been sitting for a long time and is iced over, becoming very hard. Another, newer pile of snow is nice and soft and fluffy. Part A. A person jumps and hits a pile of snow. Compare the impulse delivered to the person if they hit the harder, older pile of snow to the impulse delivered to the person if they hit the newer, softer snow. Explain your conclusion. Okay, so say the person, so we've got old snow, new snow. So imagine the person is jumping, whee, and they're about to hit it, and they've got some downward velocity v. Now that's going to be the same for both jumps, right? It's the same person doing the same jump. We're just saying, okay, well, what happens if he hits one versus the other? Well, he's going to stop in both cases, right? So final velocity is 0 for both. And here we just need to remember, for the rest of this, we just need to remember that impulse equals change in momentum. And his momentum in both cases, final momentum is 0, and his initial momentum is whatever his mass is, times whatever that velocity is. Okay? There's nothing that changes versus old versus new snow in terms of the change in momentum. Now, how quickly that change happens, that is different. But for this part, the same for both. Okay. Now, part B asks, is the momentum of this person conserved during their collision with the pile of snow? Explain why or why not. And the momentum of the person is not conserved. Why? Well, because although they're in a collision, if you just look at one of the things involved in a collision, that the momentum of that thing is drastically going to change, right? He's going from some downward velocity and thus downward momentum to 0 momentum during the course of his collision with whatever pile of snow. So, momentum of the person is not conserved. Their momentum changes a lot. Okay. That's all you really needed to say. You could explain a little more about how they're in a collision, but you're only considering one of them, and to have momentum being conserved, you have to consider a system of objects, both objects involved in the collision, but that's about the minimum that you need here, and that will do.